Hello and welcome to the fourth part of my tutorial on Hibernate Reactive and Vertx. And before we'll begin coding, I would like to briefly talk about one theoretical topic which is very important to understand before we will dive into the topic of relationships. So, the difference between objects and tables. So, how data is stored in our applications. In all object-oriented programming languages, such as Java, that we use here, we have objects, and objects are basically reflections of real-world data models that we use in our applications. So, for example, we have a task like we have here on the screen, on the left part of the screen, and this task could have different fields like strings, integers, booleans, etc. But it also could keep references to another objects and another data types such as project, user, etc. So these objects are kept within the task object as references, of course, but they are objects. When we talk about tables and how information is stored in relational databases, things are a bit different because we don't have objects, but what we have here, we have tables. So in our case, if we want to represent the same data structure from the left side, we need to have three tables: tasks, projects, and users. And all of them are connected, but they do not use references like we do in Java. Instead, they use the thing called a foreign key. So each of this entity in the tasks table has a key, for example, project ID, user ID, that use foreign keys in order to relate, and this is why they are called relational databases, to relate to other tables, such as projects and users. So, for example, if we have a task with a project ID of 1 and the user ID of 1, that means that we have in the projects and users tables corresponding entries with ID, in this case primary keys, of 1 that belong to this particular task entity. So with this knowledge in mind, let's see how we could implement these relationships using Hibernate. Okay, first thing first, let's create several new classes that we will need throughout this section. So in this section, we will introduce another data model, and it will be called project. So for this, we need to create two more classes. First one would be entity, and the second would be DTO, because as you remember, we have this separation between entities and DTOs. So without further ado, let's go to the model package, and let's create a new Java class. And this Java class would be project. And remember, we will use just a class, a normal class, not a record, because the first actual class would be an entity. So let's create this class and let's add it to Git. And the first thing here is to annotate this class with an entity annotation that comes from JPA. And we need to provide a table name as well. So the name for the table would be projects. And let's specify fields of this class. So first thing first, we need to provide an integer for identifier. So it would be private integer ID. This field should be annotated with ID annotation from JPA. As well, we use generated value annotation in order to have this value generated for us. So next fields would be also of type integer, and it is called user ID. So we will use this user ID field in order to implement what is called an object level permissions later on. So the final field would be a string, and it will be called a name. So a name of the project. So very simple implementation for now. Next thing, we need to define a default constructor. And of course, you could say that this constructor will be provided for us automatically. Yes, but it's still a good practice to have it explicitly provided, so other developers who will read this code will understand this idea anyway. So the final thing, let's create getters and setters, because entities rely on getters and setters. So let's use a built-in generator. So let's go to generate and getter and setter, and let's select all of these fields. So now we have this project entity implemented. Let's create actually a project DTO class. So let's create a new class, and now it will be a record. So it will call project DTO. So in this project DTO, we need to specify an integer for ID, integer for user ID, and finally a string for name. So this will be very simple implementation, as I said. A final thing I'd like to do, I would like to add a project repository. So inside the data package where we have all our data layer classes, let's create a new interface. And this interface would call project repository. And let's add it to Git. So likewise we did in the task repository, we will specify several methods of this contract. The first one will be future, and select the future which comes from io.vertx.core. So it returns a project DTO and I call create project. And again, it accepts a project DTO as an argument. So we have also another method that's is called update project. And again, we have here a project DTO. We have here also a feature that returns an optional that wraps a project DTO, and we call it find project by ID, and we provide here an integer ID. We also have a feature that returns a void, and it's called remove project, and also get an integer ID. And finally, we need a method to return a list of projects. So likewise we did with tasks, let's create another class that will call projects list, and this will be actually a record as well. So here what we will do, we will get here a list of project DTO, and we'll call it projects. So let's save it and let's go back to project repository, and here let's create a final method that is return a future with projects list, and we call it find projects by a user, and it accepts an integer value of user ID. So this is a very simple repository like we did with task repository in the section 2 of this tutorial. I would not implement this repository in this video. Instead, you could check the section somewhere in this corner of the video. You could get a link for the task section 2 where we implement task repository, and also you could find a complete source code of implementation in the GitHub repository, and the link would be below. Instead, let's move to relationships, because the topic of this particular section is relationships. So, types of relationships. There are several types of relationships. Basically, there are 4 of them. A small note, there is also many-to-many, but we do not cover them here. And on the screen, you see that we have one-to-one, one-to-many, and many-to-one relationships. So, what does it mean? So, the first one on the left is one-to-one. This is the simplest one. This means that we have 2 objects, and the logical condition is the following. Each and every object has a relationship with another object, and there is only one possible combination. So this is extremely rare, actually, a relationship in the practice, because we use one-to-one only when we have a strict requirement to have only one possible relationship combination. For example, we have users and we have accounts if we use an account pattern, which is called an account pattern. And in this way, each user is associated with precisely one account. So there could not be a situation when one account belongs to different users, or one user has many accounts. What's usually understood by one-to-one by some software developers is basically a one-to-many limited relationship, and by far one-to-many and many-to-one relationships are most common that you will see in programming with relational databases. So one-to-many and many-to-one, basically they are a reflection of each other. So because what we have here is basically the same structure, but we look on this structure from a different perspective. So one-to-many relationship we could understand from the point of view of the project. A project is one, and it could relate with several or many tasks. That means that each and every task has a relationship with a project, but project has a relationship with many tasks. From the other point of view, if we will talk about a relationship from the position of the task, that means that each of these many tasks has an exactly one possible relationship with the project. Or this relationship is an empty, for example, if this foreign key is a null. But this is a different story. So one-to-many and many-to-one are used together, and this is called a bidirectional relationship. However, we could also specify what is called an unidirectional relationship. So, for example, we specify only one relationship on the one side, for example, on the task side. So, here in our example, we would specify both one-to-many and many-to-one relationship. And let's see how we could do it. Okay, so far so good. Let's now implement what we learned so far about relationship in our project. So, we have here the task entity opened, and let's define a relationship between task and project. So remember, we have a many-to-one relationship. So that means that many tasks could be associated with a single project, with one project. So let's add another field here of type project, so of type of another entity, and we call it project. And we need to annotate it with an annotation called a many-to-one, which comes from JPA, and another annotation that we need to provide here is called a join column. And inside join column we specify a name of the field, because basically this is an object relational mapping framework, so we have here an object. However, on the database side we store things using foreign keys, so we need to specify a field in our data table which is used in order to keep this foreign key. So we call it project ID. And we also need to say nullable true. So nullable true is basically a default value. However, it's still a good practice to provide explicit definition for software developers that will also use our code, so they will understand about our data design. I use here nullable true because actually we could have a task without an assigned project. Another thing that we need to do here, we need to go inside the project entity, and let's add another field here. And this field would be of type of list list task, of course, and we call it tasks. And what we will do here, we will annotate this field with a one-to-many annotation, because remember that one project could belong to many tasks, and we need here to specify a mapped by parameter. And basically mapped by, we put here a name of this field that we use here. So here we use a field project in order to keep information about this entity, and therefore here inside mapped by we also specify a project. So now we have these entities. However, we need also to modify our DTOs. And before we will do it, let's briefly talk about optionals. Let's just stop for a moment and let's talk about the topic that I found interesting. I would like to talk about using optionals in records. So, in theory we know that using optionals as arguments both in constructors and in methods is a solid anti-pattern. However, when things come to records, there are exceptions. So, if we have a normal class definition with getters and setters, like we see on the left part of the screen, we could use a setter in order to wrap a possibly nullable field as an optional, and then using getter to return this optional in order to avoid manual null checking. However, with records, we cannot explicitly declare instance field and cannot contain instance initializers. In this way, we should include optional as a part of the record definition. So, what we will do now, inside the TaskDTO class, we will add another field of type optional, and this optional will wrap a project DTO class actually. and we called it project. So remember that inside our DTOs, we still could keep relationships between different objects, but we will use DTOs. So instead of using project, like we did in the task entity, here we will use project DTO. So now we have all our classes ready and prepared, and let's see how we could actually perform operations using tests. So what we will do now, we will actually verify that relationships that we have created is working. So I have created a file called relationships.test.java, and I already prepared here a setup method. So in order to reduce the time of the subsection, you could use it from the GitHub repository, and the link is provided in the description for this tutorial. And now we will create a test method, and this test method would call create relationship test. And as always, we put here a vert.x argument and a vert.x text context argument. So let's maximize this screen, and first thing first, we'll create a project DTO instance. So this project DTO will be without identifier. It will be assigned by Hibernate. The user ID would be 1, and the name could be any string you want, for example, my project. Next, we say here context verify block, like we do in all our tests with Vertx. And if you're not familiar with testing with Vertx, I highly recommend you to check my book, Principles of Vertx 2nd edition. The link is also provided in the description for this section. So let's call a project repository, create project method, and it accepts a project DTO. And then using the compose method in order to create a sequential composition, here we have a project parameter, but of course it will be not a project entity but project DTO. So first thing first, let's call assertions. In order to verify that a project was successfully inserted, we need to check that it has an ID. An ID would be of 1 because our database is empty. So it's a project ID here. And next, what we will do, we'll create a TaskDTO instance. So new TaskDTO. Also, it would be without identifier. User ID would be 1. Content could be any string, my task. Status would be false, sorry. Local datetime now for created add parameter. And finally, we have here an optional, like we already discussed, an optional of project. So of this particular instance. And then we return a task repository, create task method, and it accepts a TaskDTO. So now we specify an onSuccess handler. And inside onSuccess handler, what I'd like to do, I would like to check that the result of this operation has an assigned project DTO instance. So what we could do, we say assertions, assert true, and we say result project, and because it is optional, we could say is present. And then we say context complete now. And we also provide failure handler, so in case of failure, we call context fail now. So let's run this test. And let me maximize the console a bit. So the test is passed, and what we could see in the output, we could see that first 2 tables were created. The first one would be a project, and the second create tasks. Also, the first operation was to insert a new entity inside projects table. And this instance has an ID, the third parameter, of 1. But more interesting, when we scroll a bit down, let me again maximize because I have my face in the right corner, and it covers important things as well. So here, the project ID, which is the fourth parameter here, is also specified, and it is an integer because, again, relational database does not contain object, but it contains rows that are connected using foreign keys, and the foreign key in our case would be 1. So you see that entity that was inserted in the task, it has a project ID of 1, so it is connected using a foreign key.